Okay, moving on with Newton's second law. We've added a little bit this time. Our applied force is now on a funny angle. We'll have to do components in a way it's comparable to projectile motion. When an object was launched on a funny angle, since gravity's pulling it straight down or vertically, we took an object launched on an angle and found the horizontal and vertical parts of its its initial velocity. For this one, we've got a force on an angle. In this case, it's 30 degrees above the horizontal. Gravity's still straight down. Normal would be the reaction upward. It's asking for the coefficient, so there's obviously friction backwards. The 10 newtons, well, the applied force, 10 newtons in this question, is on a funny angle compared to which way it's accelerating. There's nothing in the question to say it's not accelerating horizontally, so we're going to go with that. It's accelerating horizontally. The 10 newtons is on a funny angle compared to the horizontal, so I need to get the components of the 10 newtons. That's kind of a key to this type of questions when there's angles. Figure out which way it's accelerating, and they get components of any force that's on a funny angle compared to the acceleration. In this case, it's the 10 newtons that's on a funny angle. I'm going to think of that 10 newtons as two separate forces. This purple side is opposite the angle, so it's going to have a value of 10 sine 30. We'll crunch that out to a decimal eventually. This side down here, I'm going to treat it as 10 cos 30. So instead of 10 on a funny angle, I'm going to picture it as a forward force of 10 cos 30 and an upward force of 10 sine 30. This is not a boring case question anymore. It's not moving vertically, or not accelerating vertically, so I know that whatever the upward forces are, they have to balance out the downward forces. In this case, I now have two upward forces. The normal is reacting and pushing upward on it, and we're pulling on a funny angle, so the 10 sine 30 is also acting up on it. Downward, we just have one force, and that's gravity. Whenever a question has the coefficient of friction, you need to find the normal. So we're going to flip this around. Normal is mg minus 10 sine 30. At any point, we could have found the decimal for 10 sine 30. It's nice and clean and even half. I just left it as letters, but you could have figured that out sooner. 2 times 9.8 minus 10 sine 30, which of course is 5. So it's like 19.6, take away 5. Our normal force is 14.6. So it started off with that component step, but otherwise it follows along like when the applied force wasn't on an angle. We're going to use the vertical to get the normal, then plug that normal into the horizontal. In the horizontal, it's accelerating, so we're going to set up F net equals ma. We've got a tug of war. The forward force isn't the full 10 newtons, it's the component, the 10 cos 30. We'll crunch that out as a number. The backward force is friction, and that's equal to ma. Friction is mu times Fn, so that's equal to ma. Now we know everything in this line except the coefficient. 10 cos 30, we could have got a number for that at any point, minus mu multiplied by the normal, which we did that work to figure out is 14.6, equals the m. In this case I made up was 2, and if you look back, the acceleration for this one was also 2. 10 cos 30 works out to be roughly 8.66 minus 14.6 times, I don't know, is equal to 4. You can double check my algebra, but within rounding, I'm getting 0.44. Same basic setup, just we had an extra step in finding the normal force. It's not a boring question since we were pulling on an upward angle. The normal had a bit of help, so the normal plus, in this case it was 10 sine 30. Those two together teamed up to cancel out gravity.